Hello, ladies and gentlemen. I'm Juan Linietsky. I am the head of development of Godot engine and the technical lead. I'm going to work on these videos and a series of videos for a while because many ask for it. Godot has a really large code base, which makes it a bit difficult to understand and to get familiar with. So the idea of these videos is to work somehow following the code base and explaining you what each bit of the code base is and what it is used for. I'm not really used to streaming or to talking on a video and recording videos and showing things, so I hope you're patient now with me about this, because again, this is not something I'm very experienced into, so the audio quality may not be the best, so this is what I can do. If you have any feedback on this, feel free to leave in the comments below. Well, I will start. I don't really have a guide on this. I only noted a few things I want to explain in which order. This will be mostly improvised, so if there is anything that it wasn't clear, again, please ask about it in the comments below. I will try to answer as best as I can. So let's start. If you have any doubt, I use Qt Creator for development of Godot. It works very well. I like that you can use it exactly the same on any platform, be it Windows, Linux desktop, or Mac OS. So it's my preferred way of working with Godot codebase. I don't really use any kind of project management. Godot has a cons file you can use to build. We use cons because we have to build for a very large amount of different platforms. We have to compile for many of them at the same time, usually when testing. So cons is one of the best tools for this job. That said, I'm not going to focus so much on the build system because there's a lot you can learn about it in the documentation. I will talk about the source code mostly. If at some point you really think you may need a tour on the build system, I can try to do it. I'm probably not the most experienced contributor to a project regarding to it because many have been doing improvements to it, so I may not be totally up to date, but I can try. So let's begin. Let's first take a look at the directories. If you download the Godot source code from GitHub, you just go to GitHub, Godot engine, and just download pretty much the source code. There's more tutorials for that. I'm not going to cover that. You can check that there's many directories here, like core, drivers, editor, main, miscellaneous, modules, platform, scene. Let's do a very quick refreshment of what every one of them is. Usually each of these directories depends on another. There's not many cross-referencing between them. The core directory is core. Everything core is here. Everything else will reference core. In core, you have everything related to core engine. All the core types, core structures, everything very basic that we used to build upon. From there on, there is the servers. After core, on the servers you have like all the interfaces exposed, like for rendering, physics, and everything, but it's still very low level interfaces. It's not really high level interfaces. After the servers you have the scene. This is the scene. The scene has all the nodes you see when you add nodes to a Godot scene from the scene tree. This is all in scene. It only contains pretty much nodes and also resources. Then finally you have main, and from main you have the main loop that runs the engine. There's some extra folders here that I will cover. One is drivers, which is things like, for example, external dependencies that are core to the engine, like, for example, operating system stuff like POSIX, Windows stuff, OpenGL. This is core. This is not something you can take away from the engine. You maybe compile it out, but it's core. Then you have modules, which is a very large amount of formats and external libraries that you can just take out if you don't want. You can, when you compile cons, you can see what you can use, what comes built by default for every platform. So modules is like dependencies that are not so hard coded that you can turn off while building. And finally, there is the editor. You can see the editor here. This contains all the code for the Godot editor. The Godot editor is made using Godot itself. Everybody knows this at this point, so it's really funny. And there's a few more things, like, for example, for the third-party libraries, we bundle everything. Every library that Godot uses as third-party is bundled into the build system. We do this because we build for a lot of platforms like WebAssembly or Android and everything, and using external dependencies for all those platforms is a really, really big hassle. So most of the third-party libraries are bundled inside. Some of them you can choose to compile out, like using the operating system provided ones. Usually this is what we do on distribution versions of the libraries. When you have a Godot distributed by like Debian or Ubuntu or anything else, usually we use the compiled out ones. When we distribute from the web page, everything is bundled in because it makes sure that you will be able to run it when you download it, especially on Windows and other operating systems that don't provide external dependencies like this. So let's go to core. Core is the more central place. Everything depends on core. Core doesn't depend on anything else. So let's begin. The first thing I will discuss is the main file. The main file is the typedef files. Here is the typedef file. You can see this file. It has very classical stuff, like very basic templates, defines, things that make it work on every platform. You have some functions for swapping things. Next power of 2 is very, very common and very core things. This is very, very core, as I mentioned. For more math specific things, then you probably have to go to the math directory. Without the math functions here, we have abstractions for most of the math functions. You can see all of them here. Nowadays, we could probably use the operating system ones, but being that Godot is pretty old and it used to be compiled for consoles, many times the consoles would even provide the math functions, so you have to do them yourself, or they have their own. So this file will provide an abstraction for this. Nowadays, it's mostly just wraps around the operating system based ones, except for some, like for example, checking if none, depending on the compiler version. You have to check yourself, or you can use operating system provided functions. So this is the math functions. I would say that next in importance is everything related to math. You can check, for example, the vector2, which is a core type, but we use everywhere. It has x and y. You can see a union here. The union ensures that basically you can just use it as a size or as a position, depending on whatever you want, x or y. It has a lot of functions for math. You can take a look at this file later, like len.product, everything sliding, bouncing, reflecting, all the operators. You have the same for vector3 with all the dot product, cross product, everything related for math. You can check, there's many of them, quaternion, rect, transform. Something on interest maybe is that we don't really use matrices directly. We use the transform structure, or more like the basis structure for 3D. This contains two vectors, so it's pretty much an orthogonal basis, meaning that it contains a transform. You don't need to really understand much about math to follow this, don't worry. This is just a comment about how it is organized. Then you have the actual transform, which contains the basis and an origin point. If you're working with 3D, you're probably used to it. If you're not working with 3D yet, don't worry, feel free to ignore this, it's fine. We have the rect2, and well, this is basically all the math containing stuff that you will need if you use 2D or 3D. So the next thing that I'm going to comment on is the OS directory inside of core. We have pretty standard OS stuff like directory access, file access. You have stuff about memory. We have our own allocator, like for example here for creating memory we use memnew instead of new. It is this macro that is around here, and we have memnew. So if you write Godot code that does something, instead of using a equals new something, you have to use memnew something. Why do we do this instead of using new? The reason is that this small thing you can see here, we have a post initialize and post and pre-delete handlers here. When initializing and deleting Godot objects, you need those because it means that we can safely track like after something was initialized and before. This works around the limitation in C++ that you can't really tell after somebody initialize an object or delete an object. We can catch better when you're managing the classes in C++. This is used everywhere in Godot. You will probably see later, don't worry. The other important class is OS. This contains all the functions that you need for accessing the operating system abstracted because it's different on every one of them. Like, for example, you can print errors, you can show dialogues with alert, you can change stuff regarding to the window and the mouse. In Godot 4, if you're using or reading about Godot 4 has this separated in a display class from OS. But since this is Godot 3, it's all together, and you can see all the functions in the OS class. You can see like all the screen count and windows, everything is also handled by OS operating system. You can open dynamic libraries, you can check the internationalized input, you can kill a process, you can execute a sub-process, you can change environment variables, pretty much everything you need, like calendar functions, timer functions, delaying, handling crashes, virtual keyboard on mobile, everything is handled in this OS class. So anything that you would typically access that is OS related, you can access via this class. We have a wrapper for script, but yeah, this is basically it. There's a few more things, like for example the mutex and the thread. These are for threading. This exists because when Godot was created, C++11 didn't exist. Now these are provided by C++11, but we still have them because scripting uses them as wrappers for threading. So they still exist, even though they probably will be used less and less within the engine core. We also have file and directory access. You may be wondering why we do this if operating systems provide these kind of things. This basically is handles a lot of things that are difficult with the operating system, like Unicode as an example. Converting Unicode paths is quite complicated as an example, especially on macOS, because they are unnormalized and you have to normalize them. It's complicated, so we just wrap everything on. For example, in some platforms you don't really access the real file system, so when you export a game in Godot, you probably have seen that it exports a PCK file. This is not accessed by the regular file system, so you still need to use this wrapper, which is file access. When you export to Android, Android puts together everything on an APK file, and you can access the file from within the APK. So we use the file and directory access, so we make sure everything is nicely abstracted and works on every platform. So you use this from your game, and from the whole engine uses this also, and make sure that we can access files everywhere. So just, if you want, take a look at file access. You will see pretty standard. We also have some serialization and deserialization functions, like for example storing integers, getting integers, storing Unicode strings, getting Unicode strings, getting a CSV when you read from a CSV file. There's all those little helpers that you can see that they are available for you if you need, even from the scripting API. For their access for directories is the same. You can iterate all the files on a directory, check if this file is a directory, it's hidden. You can get the drives on Windows. You can get a lot of different things using their directory access functions. You can move files, rename files. So this is a bit different on every operating system, so having a nice abstraction is pretty nice. So what else do we have here? Let me check. But I think from the OS side it should be okay. Oh no, wait, we have one more, which is the main loop. The main loop, you should probably, we'll probably see later again more about this. The main loop is a base class that Godot uses. It handles input events, input text, because when you are working with like mobile, you have a keyboard that pops up, so it gives you the whole string all at once. You can initialize, iterate, run on idle. Like iteration is for the physics, idle is for the graphical frames. This happens at fixed time, iteration, and this happens on whenever it can happen. It's usually synchronized to vsync. If you don't have vsync, it's going to be called as soon as possible. And then this happens when you're finishing the game. You have this small callback for dropping files. When you drag files over the screen, you will get this callback. So you implement this to make your game. Usually you don't do this because Godot provides something more advanced, which is a scene tree. We will see that much later. But it's good to know that the OS class that I showed you before, like this one, the OS class, this needs a main loop to function. There is a function that is set main loop, and you have to provide a main loop. All this is handled for you on utilization. You don't really have to do it, but what is important to know is that you can provide your own in case you really need to. You probably won't need to, but it's good to know that you can. So the scene tree class, when you're working with nodes and you ask for the scene tree, which contains all the nodes. This is also a main loop. If you check, it will inherit the main loop. It's an implementation of main loop. So basically, if you want to make a different way of handling high-level stuff in Godot that is not node-based, you want to maybe something else, you can do it if you want. It's probably a waste of time, but you can do it. One of the reasons why the engine has a main loop abstraction that is so low level is that originally we also, with Ariel, when we have our own company, we did a lot of porting work. So we would port like games and use Godot just as the cross-platform layer. So we would make a custom main loop that uses the game main loop that wasn't originally written for the engine. So this is not very common nowadays, but it just exists and you can do it and use it. So I think with OS you kind of get the idea of what it is. There's more files, feel free to explore them, but you won't find anything new or more interesting. Maybe the input event you can check later. Yeah, well, I guess when you get input, you will get this structure, which is input event. You can get a lot of them, like you can get input with modifiers is an abstract class, but you can get keys, you can get mouse, you can get joystick, mouse motion, you can get touch controls on the iPad or the Android tablets or cell phones, or even on the web. You can get, well, there's a lot of them. You can get the pinch and zoom actions like gesture. Those are all input events that you get. You generally don't need to get them from the main loop. You will probably get them from controls or input, the input callback. There's easier ways to do it from within the game. This is just a very low level stuff. So, okay, that is a node from OS. So let's see a bit what the containers Godot has. One typical argument that we hear is, why does Godot not use the standard template library from C++? We have our own templates. So why is this? There's a few reasons for that. There's not just a single one. The main one is that we don't exactly use the templates the same way as they exist on STL. We have a bit of different use case. So the ones on STL don't really quite cover what we need. So it's easier for us to use custom ones, which are actually pretty small anyway. Also, one problem STL has is that it's really, really complicated. It's something that is probably theoretically very correct. You have like multiple levels of inheritance and templates instead of templates and everything. And this is very nice, but when you compile to binary, the symbol size of STL stuff is huge. The symbols on STL are huge. You probably have noticed when you have an error with STL, when STL container, it just shows a very huge line showing what the template is, and you have C templates inside of templates, inheriting templates. STL is great, but it just is too complicated and produces really large symbols. The problem with the large symbols is when you compile with debug, your debug binaries will be absolutely huge, especially for something like Godot. So we have really simple templates and almost don't use anything complex, so the symbols are small and they won't annoy you when you build or send a small build for a cell phone or HTML file. It won't be so annoying because it won't be that big. If we use STL, it will be huge. But also it's not, we don't exactly use the same thing as they use. One good example about this is the vector class. STL has a std vector, but we don't really use that. Vector, we use the vector for little different things. Usually, most of the time we use vector for just putting the stuff in an array and passing it around, and we just pass around these vectors like with arrays a lot in code. Usually you can pass this information like from files, you can send it to servers, you can just send stuff around using vectors. We send a lot of stuff using them. So the interesting thing is that if you copy an std vector, it's just going to copy the whole thing, allocate the memory. It's kind of slow. So since we use vectors mostly for passing data around, we use this thing called codata. It contains a copy on write operator, so the vectors in Godot are copy on write. This means that you can pass the data around safely, and it's going to share the pointer. It's not going to reallocate anything. It's just going to change a reference counter. The reference counter is greater than 1, meaning that this vector is used for many places, and you try to write to it for it. It performs what is called copy on write. It just creates a local copy. So for you, you're just copying the data, but internally it's just referencing the data unless you want to write to it. In fact, we make writing explicit. So if you want to write to a vector, let me show you a bit of code here. You don't really going to do like my vector, yeah. This will fail using in Godot. For writing, you have to write explicitly like this, write 5. This makes sure that we don't create copies unnecessarily, so passing arrays is a bit more annoying because you have to explicitly write to them. But the advantage of this is that we really know that we won't be making mistakes because we will only write when you actually want to write. Otherwise, the vector will just be not checked for copy and write. I mean, when you read from the vector is fine. When you try to write to it, you need to check the references, then do copy and write. So basically, if we make sure that writes are explicit, we can make sure we have a good control of performance. So yeah, that's basically it about vector. Let's see what else we have here. Well, together with vector, we also have a string class. It's called uString because it's Unicode string. We have our own Unicode string class. We know again std has a string class, even W strings for Unicode, but honestly we need so much more stuff from strings that what STL provides that we don't even consider using it. Like for example, we have Unicode parsing, we have a lot of functions we use like for checking identifiers, valid identifiers like pat zeros, pat decimal. We have so many functions we use for parsing and for different, like for example, escaping to XML, escaping to HTTP, escaping to C. We have way too many things that we support in our string class, like proper splitting, like quick splitting, because we do a lot of parsing sometimes of text. So we need like a lot of parsing functions that they are all in string. So we use our own Unicode string. Another problem is usually that the Unicode string in Linux and some platforms is 32 bits. We are still using 32 bits, but I think the plan in Godot 4 is to make it UCS 16 as standard, so it uses less memory for all the strings. These strings also use the code data, copy and write. So strings are also copy and write. You can pass them around and they will not really be copied. They will just be referenced. And when you try to write to one of them, it's going to then create a local copy. So it's important to know that. We also have a few more classes like set and map and hash map. And well, we have all those classical templates. Those are more similar to STL. Maybe what is different is that when you iterate them, you just use very explicit pointers. This is so it's just more explicit. We have forbidden in C++ 11 like the use of auto and these kind of things because we always want to make the code very explicit. It helps a lot to understand it when you read it, and when you're reviewing code especially, it also helps a lot because you don't have like the editor like this to check what a type of something is when you're on GitHub reviewing pull requests. So having all the code very explicit, it helps a lot for the contributors to review everything sent by your own contributors. If it is just a library you're writing on your own, maybe you will fill everything with auto, then nobody will be able to understand how the library works. But well, this is a project that almost 1,000 people contribute to, so we make code very explicit to make it readable. So what's next? Okay. One last thing. This is RID. The RID class. This is just a wraparound around an integer. This is used as an opaque reference to a resource. You don't need to know anything else about this right now, just that it exists. The RID is a type that we have in the engine. It's used together with servers. When I explain servers a bit more in detail, you will understand what RID is used for. But right now, I suppose just better hold on. I think the recommended way of seeing this video is probably to stop and check the source code. Let's just stop the video and check the source code of what I am discussing so you understand it a bit better than you just unpause the video and continue. So what is next? I think we finally reached the object class. So this is object. So object is the base of every allocated object on the heap, I guess, from Godot. You just inherit everything, all the nodes you see, everything you see that you can access from GDScript, like for example, or C# that is not a core type like vector or anything like that. Anything that is not those few core types is derived from object, so everything inherits object. So this creates a custom kind of dynamic type with reflection in C++, which again, we're just working around the C++ limitation. So what does an object do? You can check object here. It has a lot of stuff. Let's check the public API. So what object does is clearly more obvious. So object has a cast to thing that you can use to cast to other types. It's like dynamic cast in C++. Actually, it does use dynamic cast, as you can see here, normally. But you can compile Godot without RTTI, which is what provides dynamic cast. And then Godot will use its internal casting system, which is the one you see below, that by default it's not used. So some platforms like Android or HTML5 use the no RTTI option. That means that Godot won't use dynamic cast and it will use its own system. Why does it do this? Well, RTTI uses a huge amount more of binary size and probably a bit more memory and a bit more performance. So not using RTTI mostly shrinks the binary like 20%, so you can make smaller binaries. So Godot uses its own system for this by shrinking a lot the binary. So not having RTTI is pretty cool because, having the option to not use it is cool because you can shrink the binary. It has a very small performance cost, but you have a lot smaller binary. We also don't use exceptions in Godot. This is something that you will see by default. I will go back to object in a bit and show you something I forgot, which is the error macros here. Instead of using exceptions, we have this list of macros that you can just check a condition and just fail. The idea in Godot is that you will never really throw an exception, because if you throw an exception, somebody has to catch it pretty much and then has to nicely survive it. This actually never happens and things just crash. And when you're working with game development and you ship stuff, you are probably wishing that things don't crash and just continue working. So with exceptions, even a small error can crash for you. So with Godot, all error handling is designed so you don't really need to catch anything. Godot will just throw an error telling you what happened and giving you a log. And even if you're using the debugger, it's going to show you which line of scripting originated the error. It shows an explanation of the error, the function, everything, but it will try to do its best to survive. So it won't fail easily. Godot will just survive pretty much everything and it won't crash. You can probably see that if you use the editor, it's very difficult to crash. Because of the way it's designed, we are very defensive with any kind of validation for arguments for any function. We'll try to validate them, and if something is wrong, we'll throw an error and try to continue going on. Godot will always try to survive, and no matter what, and it's programmed for that. So let's go back to objects. We're checking object. Those are just the error macros. The file is errormacros.h. So let's go back to objects. Objects have a few things besides the type. For example, I will show you in code here. You can just, for example, get an object like object, get a class. You can get a string for the class. You can use, for example, you can get, let me show you signals. This is important. Objects have a list of signals. You can connect the signal to anything you want. If you have learned how to use Godot, you probably know already what signals are in Godot. You can even check the object reference. You can do call deferred, which is pretty important. This means that all the call goes to the message queue. This message queue is this one, the message queue class. This is a queue that has functions that are, you can push a call, push a notification, push a set, because you can have properties exposed in object. So objects have this thing that is, you can set and get here, and you can call a notification. The notification is just an enum, it's just an integer. Every object has a different notification. And then it has some macros here. It has some really complex macro magic. So for example, I will show you like the node that is the regular node, I guess, node.h. This is on the scene, but I will show you as an example. You just inherit object. You have to put this macro here, which is like GD class, the type of object you're creating, and the one you're inheriting. This creates, like, if you see here, well, it is not working. You can check in the object.h. This macro is in there. Let's go there. It's here. It just creates all these in every class, which allows you to set and get, call notifications, do a lot of different things. So you can see that objects have a notification here in the protected part. You can see, like, for example, you override notification. You can inherit and override this as many times as you want, and it's not like inheritance is going to be called in every level. You can use set and get if you want to wrap for setters and getters, or you can use the binder system. The binder system is also overriding this. You can override on every level. It's a static override, but it works kind of like a static inheritance. It's pretty cool. You just define this in your class and it's going to work. Again, you can check a bit more in detail this in the documentation we have on the website. I'm just doing more like an explanation of where everything is and what everything is. So when you call bind methods, which is here, let me show you bind methods. This is a static function, and you call this class DB bind method. So you use object together with class DB. This is class DB. Class DB has, like, you can bind functions and everything for it. And then the two reasons why you use class DB is to register, like, the notification, the functions. You just kind of expose everything an object has via class DB, and then the scripting APIs can make use of the object. So you can see, like, for registering a class, registering methods, if you go back to where we were, you can see that node will just register all the methods here. Again, you can check tutorials like on this. It is more explained in detail. I'm just going to do an overview of what everything is and everything. So class DB pretty much is what binds the engine to scripting. You still need to use class DB if you want to receive a signal. For example, if you want to get a callback from a signal on C++, you need to bind that method by a class DB, because signals use the dynamic system that scripting uses also. So this is why you can also see signals from script and connect them from script, unlike other systems that just use the C++ templates. So what's next? I will also add this call. We'll also check this file. What was the name? No, string name. Yeah, string name. This is another. This is the GD native one. Where is the class? String name. It's core string name here. It's in core. Let's go back to core string name here. So what is string name? What is the difference between string name and a regular string? Well, string name is like a pointer to a string. It's a unique pointer to a string. When you create a string, you can create it from a char string, like char pointer, or you can create it from a regular string, the one we saw before. But this will check if the string is registered in a table. It has over here, like this table of strings. It's like a static hash table. If the string already exists, it's going to give you a string name that contains a pointer to the existing string. So these are actually unique. Every time you construct a string with the same string, it's going to be the same pointer internally. Why is this used? Well, you can use this to compare very quickly strings. So instead of having to compare character by character, you just compare the pointer. If you check here, like operator equals, just checks that the pointer is the same. Even operator less, you can check that the pointer is the same. So you can use a map or a hash map with this and very quickly check the strings. So when you have a string registered somewhere and you just want to check very quickly, like for example, when you play an animation, you pass the name of the animation. You pass a string, but usually it's a string name in most of the cases. So Godot uses, like for connecting signals, playing animation, uses strings a lot. but they are not really real strings. They are actually string names. They are pointers. So all the comparisons are super fast. You can quickly find whatever signal, animation, whatever you are going to use, because it's just a pointer. This is unfortunately not exposed in the scripting API. The idea is to change this for Godot 4. In Godot 4, you will be able to use string names from scripting. So you will add, like, I don't know, whatever, something to the string. So you will be telling it that it's a string name. Or the compiler will detect itself, because we now have static typing. But yeah, string name is just a faster way to pass strings, because they are pre-saved and registered, and they are supposed to exist beforehand when you use them somehow. So what is next? Okay, next, I think it should be interesting to check variant. Or actually, we could leave variant for the next one. You probably will be a bit busy with all this, checking all these files. So let's do an overview of what we saw today. We checked the typedef file. We checked the math headers. We checked the OS class, which abstracts most of the OS stuff. We checked the main loop. Main loop is probably not something you really need to use, but it's good just to know that it exists. We checked Godot templates, the vector and everything we know, that they use copy on write. We checked the string also, which is similar and also uses copy on write. We checked the object class, which is the base for every non-core type in Godot. Again, every object or everything, like from physics and nodes and everything you access, even the resources, everything you access from the scripting API, it's all objects. And they have all their functions exposed by a class DB. So they expose all the functions and properties and notifications and constants. It's all by a class DB. Well, we check a string name, which is a way to having unique strings. I'm going to show you a bit more about that before I forget. So in object, when you connect a signal, where is the connect function? Here. You can check that it always uses a string name. It never really uses raw strings. It's just string name. So yeah, that's what string name is for. You can again just research all these topics for now, so you get a better handle of them. Guess the next video I will describe more things like reference, variants, and everything. But I think for today this should be okay. If there is anything you think I should be doing to make these videos easier to listen or more scripty or anything, just let me know. This is the first time I try doing this, so any feedback is very appreciated. Well, okay. It's been a pleasure, everybody. Thank you very much.